I'm Ben Lazenby, this is A2 speed and velocity. Distance is the extent or amount of space between 2 points regardless of direction. Distance is classed as a scalar, and an example of a distance would be 200 metres in the 200 metre swim race. In the picture shown below, there are multiple distances between certain points on a football pitch. For example, the distance between the goal line and the penalty spot is 8 yards, and the distance of the length of the side of the pitch is 60 yards. Another example of how to find distance is adding up smaller distances in between the 2 points. If you're trying to find the distance between the goal line and the 18-yard box, you would add the 8 yards to the penalty spot with the 2 yards to the edge of the box from the penalty spot. This will show you the distance between the goal line and the 18-yard box is 10 yards. Displacement refers to the distance a person or object has moved in a straight line in a given direction from the starting point. It is a vector quantity because it has magnitude and direction. Displacement is the direct, efficient route taken between points A and B. In the example below, we can see the displacement is smaller than the distance. Instead of going all the way around, the person has cut across from point A to point B. They have taken the more direct route, which will take less time. Another example would be if a swimmer swims 50 metres in a 25-metre pool. The displacement would be 0 because they end up at the same point which they started. Positive and negative refers to a direction. For example, positive could be classed as north, which is the direction the swimmer goes in for the first 25 metres, and negative could be classed as south, which is the direction the swimmer goes in for the second 25 metres. Speed is the ability to move all parts of the body as quickly as possible. It also refers to how quickly a distance can be covered. Speed is measured in meters per second and is represented as S in equations. Dina Asher-Smith is a British female sprinter, and her fastest record time for the 100 metres was 10.83 seconds. The equation for calculating speed is distance divided by time, and it is represented like this in an equation triangle. Distance is represented with a D and time is represented with a T. In this case, Dina has travelled 100 metres, which is distance, in 10.83 seconds, which is the time. To work out her speed, we'll have to do 100 divided by 10.83, which equals 9.23, rounded up to 2 decimal places. We know that speed is measured in metres per second, so she's travelling at 9.23 metres per second in 100 metres. Distance time graphs represent the speed of a given object or person. In the examples below, the graphs show different types of motion. In the first graph on the left, there is no motion and the person or object is stationary. There has been no distance gained. The second graph shows a constant increase in motion the whole way. There is a constant velocity over the time. The third graph shows acceleration. The gradient is steeper, showing the speed has increased. The final graph shows deceleration because the distance has decreased over time. These graphs will be used to analyse certain athletes in different sports. For example, the acceleration could have been based off a sprinter who is accelerating in the 100 metres. The deceleration could be calculated as the 100-metre sprinter slowing down after they have crossed the line. There are different motions going on in this graph at the bottom. From A to B, there is acceleration because the gradient is getting steeper. There is no movement and the person is stationary between points B to C, and there is the deceleration after point C. This is where the athlete would have finished the race. Velocity refers to the rate at which an object changes its position. Velocity is represented with a V in equations, and it is measured in meters per second plus direction. You could say a runner is running at 10 meters per second west. Velocity is calculated by total displacement measured in meters divided by total time taken, recorded in seconds. A couple of examples would be in tennis and in cricket. Serena Williams has served the ball. The ball travels 9 meters north in 3.2 seconds. To find the velocity, you would have to do the total displacement, which is 9 meters, divided by 3.2 seconds, which is the total time taken. 9 divided by 3.2 is 2.81, rounded to 2 decimal places. Velocity is measured with direction as well, so the velocity of the ball is 2.81 meters per second north. In cricket, Ben Stokes in the Ashes hit the ball 86 meters west in 4.6 seconds. To find the velocity, you would do the displacement, which is 86, divided by the total time, which is 4.6 seconds. The answer is 18.70 meters per second west. Velocity time graphs. These graphs show velocity, acceleration, and deceleration. These three examples below show different movements. The first one shows movement at a constant velocity, and the second one shows the body is moving with decreasing velocity. This is known as negative acceleration, also known as deceleration. The final one shows the body moving with increasing velocity. These graphs are used in running to track the velocity and speed of the runner at different periods in the race. A runner in a 100-meter race will be stationary and then accelerate to increase their velocity for the main bulk of the race, and then they will decelerate when they reach the finish line.